Alright, so, probably think I'm crazy for continuing to talk about this, and probably the way I was talking about it in the first place. But, just looking at this again real quick. So I'm saying that, you know, based on these rules, it's possible to dynamically reallocate our definition of a unit, and that can render something like it turns this into not being a function, right? So 1 and 2 can be the same thing, even though we've already defined 1 by the time we get to 2, right? Because we're dynamically reallocating it. We're saying if our definition of 1 is how far we've traveled at this point, then however far we travel, that's 1. So we add that amount to where we're at, and basically what happens is we're always doubling, right? And you probably think, well, that's a really weird way to interpret that. The thing is, we actually do this with our number systems, right? So let's drop this in here. So here we've got 0. Now let's travel some distance, and that will be 1. And then we travel the same distance, and that's 2. And then we travel the same distance, and that's 3. So here I'm actually using this as my unit consistently, right? There's 4, there's 5, there's 6, there's 7, there's 8, there's 9. What happens here? Because this is all the symbols that I'm using. What happens here? This gets reallocated. It becomes a new unit. And now we want to travel this far to get to 2. And we travel, what was that? That far again to get to 3. This is how our number system actually works. So this could be millimeters and these are centimeters, this, you know, or if we adjust the numbers a little bit, we can get inches to feet to yards to, you know. This is how we actually use units in the real world. So it is actually very, 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 very strange to me that this potential behavior was not recognized here, because number systems and unit systems like this, particularly metric, existed before this was formulated. So the fact that they sat there and did not recognize that this was a possible interpretation of these rules is fucking ludicrous. It's frankly absurd as fuck. Because this is actually what we do. We get out to a point, and instead of trying to name, give a unique name to every number that we come across, we rescale and use a different unit at some point. And, you know, like binary works this way. So here's binary. So we go 0, 1, 2, and then the next one is going to be double that, 4, and the next one is going to be double that, 8, and the next one is going to be double that, 16, right? And I think we can even go further than that. Get out to 32 right here. Right. So effectively, these are new units. We're rescaling because we only have these two symbols available to us. So we have to rescale frequently. Here we have more symbols available to us, so we don't have to rescale as often. But we are rescaling. We are redefining our unit. Just as much as this is a unit too. And 10 of these would also be another unit. That's how this works. That's how your number system works. That's what the zeros are indicating there. That what we've done is we've jumped out. So this is our third order unit, or fourth order, fifth order, sixth order. Right. This is our second order unit. So if you like, you could put a decimal in front of these, or you could put a 0 after this, or however you want to handle that. But the point is, this is a 1 here because it is a new rescaled unit. So what we've done is we've gone out some distance and then rescaled our unit. And if we're working exclusively in these units, according to the successor function, this is the first successor to 0. If this is our unit, then this is our first successor to 0. So that problem that I'm pointing out is a very real one, which we actually exploit to make number systems work nicely. So it's not this isn't me just like being weird and pedantic and possibly even wrong. We actively use this. I'm not wrong about this. We do use this. This is a very real thing, right? So, and it's actually actively looked at as a benefit of the metric system, right? Because what you do is every rescaling is at the same point where you've run out of these symbols. Whereas, with so like inches to feet, right? It goes like this. So you got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then we're at 1 foot, and then we're at 2 feet, and then we're at 1 yard, two yards. Right, so this is inches, feet, yards. This is centimeters, decimeters, whatever, grams, decagrams? Yeah, something like that. And this is binary. But you always end up having a rescaling right here. Rescale, 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 and here you get it all over the place. It happens often in binary, right? And as I point out, each of these places where you're rescaling is the successor to 0. Every single one of them is the successor to 0. So, and this 1 is the same as 12. And this 2 is the same as 24. And this 1 is the same as 3 and the same as 36. So the thing that I'm saying is very real, and we actively use it. We actively utilize it in order to make our number systems and our unit systems operable in the real world.